Hey, Math Journey! Today, I've got something truly intriguing for you. Imagine this. What do you get when you add the square of the tangent of 20 degrees, the square of the tangent of 40 degrees, and the square of the tangent of 80 degrees? Sounds tricky, right? Well, these angles might not be the most famous ones, but what if I told you there's a fascinating connection between them that makes solving this problem a breeze? Curious yet? Let's dive in. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. Alright, let's get to it. The first thing to note is that these angles, 20, 40, and 80 degrees, might not be standard angles for which we memorize the tangents, but they share an important feature. When you multiply each by 3, you get well-known angles. Watch this. 20 degrees times 3 gives us 60 degrees. 40 degrees times 3 gives us 120 degrees. And 80 degrees times 3 gives us 240 degrees. These are all angles where the tangent values are well known. So instead of directly calculating the tangents of these angles, we'll focus on their triples. Here's what we know. Tangent squared of 60 degrees equals 3. Tangent squared of 120 degrees equals 3. The tangent squared at 240 degrees also equals 3. Pretty interesting, right? So, we've discovered that the squares of the tangents of 3 times these angles are all equal to 3. But what we need is the sum of the squares of the tangents of the original angles, 20, 40, and 80 degrees. So, let's express the tangent of 3 times theta in terms of the tangent of theta. Here's the formula you might remember. Tangent of 3 theta equals 3 times tangent of theta minus tangent cubed of theta, all divided by 1 minus 3 times tangent squared of theta. Let's break it down. We'll set tangent squared of theta equal to x, and plug that into our equation. 9 times x plus x cubed minus 6 times x squared, all divided by 1 plus 9 times x squared minus 6 times x equals 3. Simplifying, we get a cubic equation. X cubed minus 33 times x squared plus 27 times x minus 3 equals 0. Now, here's where Vieta's formulas come into play. Vieta's formulas are incredibly useful when dealing with polynomial equations like the cubic equation we just derived. Here's the general idea. If we have a cubic equation of the form a times x cubed plus b times x squared plus c times x plus d equals 0, it can be factored into a times x minus x1 times x minus x2 times x minus x3 equals 0. Where x1, x2, and x3 are the roots of the equation. Now, Vieta's formulas tell us about the relationships between the coefficients b, c, d, and the roots x1, x2, x3 of the polynomial. 1. The sum of the roots is given by x1 plus x2 plus x3 equals minus b divided by a. 2. The product of the roots is x1 times x2 times x3 equals minus d divided by a. In our equation, the coefficients are as follows. A equals 1, b equals minus 33, c equals 27, d equals minus 3. Using Vieta's first formula, we can find the sum of the roots, which correspond to the sum of tangent squared of 20 degrees, tangent squared of 40 degrees, and tangent squared of 80 degrees. x1 plus x2 plus x3 equals minus 33 divided by 1, which equals 33. So, the sum of the squares of the tangents of these angles is 33. How cool is that? If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.